Okay, so let me just continue, but it's not too good if you can't can I hear from you?
Yeah.
Okay, so let me, I'm trying to, okay, yeah. Okay, you are with me, thank you. So maybe we can just quickly recap what we did. So find the number of ways in which the letters of the word shallow can be arranged if the two L's must not come together. Then if the two L's must also what must always come together. And I told you that one thing is that if there's no condition at all, if there's no condition at all, we have the word shallow. So in how many ways can we do that? The word shallow. So if you look at it, we have 1, 2, 3, 4, 5, 6, 7. So we have seven letters. So actually they didn't ask this question. So if there is no condition at all, so we are supposed to have 7 factorial, then divided by the number of repetitions. So we have 2 repetitions. L repeated twice. L has been repeated twice. So that will be 7 factorial over 2 factorial. 7 factorial is 5040 divided by 2. That will give us 2520. So, but in this case now, they didn't ask of this particular question, but what they have actually asked is if what the question A says if the two L's must not come together. So if the two L must not come together, it means you isolate it and remove those two L's from there. So you just deal with sha-o. So then the two L's, just leave them first. So in this case now, in how many ways can we write this one, shall? How many letters do we have? 1, 2, 3, 4, 5. So that would be what? 5 factorial. Is there any repetition? There is no repetition. So you don't need to divide by anything. So no letter has been repeated. So you don't need to divide by anything. Then the next thing is now, how do we now slot in the two L's? The two L's. So what you are going to do is that you create a vacancy here, a vacant position here. You create a vacant position here. So you can come and put the L, one L here, one L here. Or let me say first one L. This L that is occupying the 4th position. Let's see, where can we put it? We can put it here, 1. We can put it here, 2. We can put it here, 3. We can put it here, 4. We can put it here, 5. We can as well put it here, 6. So that would be what? Times 6. Now, if eventually we have what? We have filled, we have placed the first L in a particular position. So if it is this place that we eventually put it, you now look at the second L. Second L, we have how many possible ways? That's 1, 2, 3, 4, 5. So it has 5 different ways. The first L, you can fill it using 6 different opportunities. The second L, you have 5 different opportunities. So now, because they are repeated letters, they are the same letter. So repetition will appear. So it means you have to divide by the number of L. How many L do we have? 2. So you divide by 2 factorial. So at the end of the day, we are going to have Riskat, you are actually disturbing us. Fumilayo Riskat, your noise, please. Okay, so in continuation, so because we have L, those L, the L occur twice, so it means we have this. So that would be what? 5 factorial multiplied by 6 times 5 over 2 factorial. So 5 factorial will be equals to 120. Then 6 times 5, that's 30 divided by 2, that's 15. So that would be this. And that will eventually give us 1,800 number of ways. Then the second one says that what? If the L's must what? Must come together. Now you can see the approach we use here. So one thing you have to know is that if the shallow that we have here, when you want to permute them, is either the L are together or they are not together. So for being together, adding being together with being separated, it should give us no condition. That's 520. So we may not even do that one. We may just say the answer to this one is 2,520 minus 1,800. We can actually approach it that way. Another way in which you can also do it, is to just say that what? Shallow. So you are now going to take them together, you bind them, you tie them together. When you tie them together, they become one. So that anywhere one go, the other will follow. In such a case, now, how many letters do we have? We have letter 1, 2, 3. This one will be together 4. This one is 5. This one is 6. So it means we have 6 factorial. Exactly. So we have 6 factorial. Now, if you look at them, in how many ways can we tie the L together? In how many ways can we tie the what? L together? Because they are the same thing. Assuming they are different number, like A and B, we can tie A, B, or tie B, A. So those are the 2 different ways in which you can tie something of this nature. But in this case now, we have L, L. They are the same thing. If I want to bring this L to the first, bring this one, it doesn't change it. It's still the same thing. So it means you have just one way. So we just have one way of tying them. So 6 factorial will give us what? 720. So that's the answer. Now, if you look at it, 720, if you add it to 1,800, you what? You get what? 2,520. So that is so can I get anybody to do the second one? I'm waiting for any of you. So can somebody unmute himself and look at how we can do that one? So can I get anybody to do that? I'm waiting. Can anybody try that? Do you mean that nobody can do that for me? Can you chat if you cannot talk? I've not seen any chat. Please, I will prefer you communicate with me. I can't get any feedback from you. It's not all that good. At least you can just even use the chat room to say one or two things. It's not compulsory that you get it. So, all right. So, let me continue. Okay, just join today. Okay. All right. Okay, no problem. Just I'll maybe by the time I'm explaining the second one. Okay. Actually, we are talking about combination. You will have watched the earlier videos. Just watch last week video. I think you'll get it. If you're able to watch last week video, you should get it. And that's why we always make the video, so that for those that are just joining, they will be able to catch up with us. So the next question, he said, how many numbers greater than 3,000 can be formed from the digits 1, 2, 3, 4, 5? We want to form numbers greater than 3,000. So numbers greater than 3,000 from the digits 1, 2, 3, 4, and 5. So in this case now, looking at 3,000 is how many digits? This is 1, 2, 3, 4. But now this is what? Just 5 digits. This is 5 digits and I have 4 digits here. Greater than, so it means I have 4-digit numbers that are greater than 3,000. I can have 4-digit numbers greater than 3,000 that I can form with 1, 2, 3, 4, 5. And I can also have what? 5-digit numbers. An example is if I remove all the comma here now, I form 1, 2, 3, 4, 5. It's a 5-digit number. That is 12,345. It's a 5-digit number. So now I don't have any issue with 5-digit number. What I will just do is that what? 5 permutation 5. Exactly. Because I'm arranging all the 5 numbers. I'm arranging all these 5 numbers out of 5 numbers. So for 5 digits, I don't have any issue with that. For 5 digits, I'm going to have what? 5 permutation 5. And from 5 permutation 5, what do we mean? From our definition, it means what? 5 factorial divided by 5 minus 5 factorial. That's from our definition. So 5 factorial is what? Is 120. 5 minus 5 is 0. 0 factorial is 1. So at the end of the day, 5 factorial means, for those that are just joining, 5 factorial means what? 5 times 4. 5 times 4 times 3. Sorry. Okay. So like 4 digits and 5 digits, and I'm on 5 and 5 digits. So I'm trying to talk about 5 factorial. So like I said, 5 digits. Like I said, 5-digit number. Okay, that's great. Okay. So 5-digit number. For 5-digit number, we have 5 permutation 5. So 5 permutation 5 means 5 factorial over 5 minus 5. That's 0, 0 factorial. So, and in that case, that one will give us 120. So we don't have any challenge with that one. We don't have any challenge with that 120. But in this case now, if it is 4-digit number, for 4-digit number, how do we do it? Like I explained last week, in 4-digit number, we want to form 4-digit number. We can just pick any 4 here. If I pick any first 4, for example, I'm going to have 1, 2, 3, 4. So I'm going to have 1, 2, 3, 4. That is 1,234. So if I have 1,234, it means it is not up to what? It is not up to 3,000. They say it must be 3,000. So that is where the condition comes in. So it means not just any number can start. It means 1 cannot start such. 1 is starting here. That's why it is not up to 3,000. Let me use another example. If 2 should start, I'm going to have 2, 3, 4, 5, for example. 2, 3, 4, 5 is not also what? Up to 3,000. So it means that 1, 2, 3 can 1, 2, 1 and 2 cannot start. But let me start with 3, for example. If I have 3, 1, 2, 4. 3, 1, 2, 4. You all see that 3, 1, 2, 4 is what? Divisible. Sorry. We are talking about numbers being what? Being greater than 3,000. So 3, 1, 2, 4 is greater than 3,000. So as a result, you can do that. So it means 1 cannot start, 1 can start, 2 can start. So it's only 3, 4, 5 that can start. So meaning that I have 3 numbers can start, which is 3, 4, 5. Now, if eventually, that's the only condition that you have there. If eventually I picked 4 to start, but we know that we have 3 ways of starting such number. Is either we start with 3, or we start with 4, or we start with 5. So that is 3 different ways of starting. So that is how we can do that. Now, others, we are looking for 4-digit number. I've done how we can start. We have done this. Now, for the remaining 3, I need 3 more numbers. Any number can come second, third, and fourth. Out of how many numbers? If I've picked 4, it means I have how many numbers left? 1, 2, 3, 4. I have 4 numbers left. Out of those 4 numbers, we need to select, or we need to arrange just 3 numbers. We need to arrange 3 numbers. So it will be 4 permutation 3. The remaining numbers are 3. If we are done with the first one, the remaining one will be 3 numbers. And we have 4 numbers left. So out of 4 numbers, pick 3. So in how many ways can we arrange 3 numbers? That's 4 permutation 3. And 4 permutation 3, how do we do that? We say 4 factorial over 4 minus 3 factorial. 4 minus 3 is 1 factorial. So 4 factorial will give us 24. So that will be 3 times 24. So which will give us what? 72. So it means for 4-digit number, it is 72. For 5-digit number, it is 120. So you add them together. When you add both of them together, 120 plus 72 will give us what? 192. So that's it means how many numbers greater than 3,000 can be formed from the digits 1, 2, 3, 4, 5. There are 192 different numbers that we can form in that particular situation. I hope it is clear. So I can't get your response. If it is not clear, let me know. Actually, I've explained all this last week. So I expect that even if it is not clear last week, okay, thank you. All right, thank you very much. So let me move. The next one, we said 3 letters of the word digits are to be permuted. In how many of these permutations do the eyes come together? Are the eyes separated? Now, let me, just like I did for number 1, in some cases, they may ask you a question of this nature and no condition will be given. So if no condition is given, how do we actually do it? The word digits. If you look at the word digits, how many letters do you have there? 1, 2, 3, 4, 5. 5 letters. So it should be 5 factorial or 5 permutation 5. So now, because there are repetitions, some letters are repeated. I is repeated. How many times? 2 times. So that is why you have 2 factorial divided by 2 factorial to remove those repetitions. Because by the time you swap the 2 i's, it doesn't change it. It's forming the same word. It's still forming digits. For example, in this case, if you swap the 2 i's, you still have digits. So 5 factorial is what? 120 divided by 2. That's what? 60 ways. But that is not what they have asked us. They have not asked us anything about this. So leave this alone. I just want you to be aware of it if no condition has been given. But in what they have given us now, the conditions have been given. So the first condition here is that what? If the 2 eyes must come together. So you bring them together, DIIGT, for example, something of this nature. So as you are bringing them together, since they say they must be together, it's not easy that they be together except you tie them up. So tie them. When you tie them like this, it means they have become one. Wherever anyone go, the other will follow it. So in such a case, so what will happen? So we are going to have I. So we have how many letters now? 1, 2, 3, 4. It means we are having 4 letters because the 2 I's have been combined together. So in this case now, we are going to have 1, 2, 3, 4. That will be 4 factorial. Now, because the I's, in how many ways can we tie the I together? Since they are the same I, they are the same letter. So it doesn't make any difference by the time you swap them. So it means you can just tie them in just one way. So our answer is 4 factorial times 1, which is what? 24. 4 factorial means 4 times 3 times 2 times 1. So that's the solution to that particular one. Now let's talk about the second question. The second question says, if the eyes are separated, like we did question number 1, so you isolate the letters, digits. We have DGT. So isolate the 2 eyes. So for DGT now, how many numbers do we have? We have 3 letters. In how many ways can we permute the 3 letters? In how many ways can we arrange the 3 letters? That's 3 factorial way. So if we can arrange them in 3 factorial ways, we have I. We will now come here and say the I can be here, 1. The first I can also be here, 2. The first I can also be placed here, 3. The first I can also be placed here, 4. So it means it has 4 ways of being what? In which we can insert it in these particular letters. So for the second I too, if the first I has eventually taken one position, for example, if it has taken this position, it means the second I can only take 1, 2, and 3. It can only take 3 positions. So it has 3 ways of being located there. Exactly. But because they are identical letters, they are the same thing. So you need to what? You need to avoid repetition. So as a result, you are going to divide by 2 factorial. So that is it. So it means you are going to have 3 factorial times 3 factorial is 6 times 4 times 3 over what? 2 factorial is 2 times 1, 2. So 2 here 1, 2 here 2. So that will be 2 times 3, 6. 6 times 6, 36. So that's 36 ways. You know, I said it that in this case now, this and this, when you add them up, it should give you no condition. So 24 plus 36, you can see it's giving us 60. So it suffices that you just, when you are asked such a question, you may not do this one, the second one this way. You can just say 60 minus 24 if you have got this. So you are also allowed to do that. So that is how we can do that. For number 4 is a little bit high. So, but notwithstanding, I'm going to explain it. So it said how many even numbers greater than 5,000 can be formed using the digits 1, 2, 4, 5, 6. 1, 2, 4, 5, 6. 1, 2, 4, 5, 6. So how do we do that? So in order to do that, what you can just do, how many numbers, even number, how do we recognize an even number? I think I explained this one to last week. How do we recognize an even number? So we can recognize an even number based on the what? The number that is what? That is ending it. Even numbers are numbers divisible by what? By 2. So there are numbers that are divisible by 2. So how do we recognize them? You can easily recognize them by getting fetching the last digit. If the last digit divisible by 2, if it is divisible by 2, it means there's no problem. So now to solve this, how many even numbers greater than 5,000? Now 5,000 is how many digit number? Just like we did number 2, 5,000 is 4 digit number. And how many numbers, how many digits have we been given? We have been given 1, 2, 3, 4, 5. 5 digits. So it means we can have 4 digit number greater than 5,000, and we can also have what? 5 digit number greater than what? Greater than 5,000. So for 5 digits, we should not have any problem. For 5 digit number, we shouldn't have any problem. So it means we are using all the what? All the digits. Exactly, because all 5 digit number are greater than 5,000. The first 5 digit number that you can form here will be, if you use all the letters, it will be 12,456. 12,456. 456. So you can see that this number is greater than what? 5,000. So all 5 digit number are greater than 5,000. So the only thing that we just need to ensure here is that we have to ensure that what? The number is even number. And how do we ensure that? It means we look at what will be the last digit. If this is the first digit, second digit, third digit, fourth digit, and fifth digit. So we only take care of what will be the last digit first. So not just anything. One cannot end because that's not an even number. Two can end. Four can end. Five cannot end. And six can end. So it means in this case, we have three numbers that can end. So we have two can end, four can end, and six can end. So what you are going to be putting inside these boxes, they are the number of ways in which you can fill those positions. So the fifth position, the last position, we can fill it in three ways. We can either fill with 2, fill with 4, or fill with 6. So we have three options. Now the remaining ones here, you can fill them anyhow. So how many ones do you want to fill now? You want to fill 4, 1, 2, 3, 4, 4 numbers. Permutation. Out of how many numbers will be left? You know, all of them, they are what? They are 5 in numbers. They are 5 in numbers. Okay, sorry for that. So, now, how many? We have 4. We'll be having 4 digits left. If eventually we took 4 to end, it means we will have 1, 2, 3, 4. 4 numbers left. So it will be 4 permutation 4. So to fill all these ones, it will be 4 permutation 4. Or you come and start at the beginning here and say, okay, since I filled the last one, so I can come here. I have 4 numbers. So I have 4 ways of filling this one. If I eventually select one number out of those 4 here, I will be left with 3 numbers. All the 3 numbers, I can put any one here. If eventually I put one of the numbers here, I'm going to have 2 numbers left. I can put any of the 2 numbers here. If eventually I put one number here, I'm going to have what? 1 number left. So I can put the 1 number left here. So, or you say 4 permutation. So whichever one you do, if you are going to use it like this, it will be 4 times 3 times 2 times 1 times 3. And that will give us 72. So if you are using this method, you just say 4 permutation 4 multiplied by the 3, which is for the last one. So 4 permutation 4 is 24 times 3. And that will give us 72. So it means 4-digit number or 5-digit number. For 5-digit number, we can fill that. We have 72 ways. Now let's go to 4-digit number. 4-digit number, you have to be attentive here now because it's somehow trickish. You have to look at it very well because now if you want to talk about 4-digit number, let me draw my box again. Digit 1, digit 2, digit 3, digit 4. Digit 1, digit 2, digit 3, digit 4. Now, because of the fact that number 1, there are conditions. The first condition is that it must be greater than 5,000. So I can't just put anything to start. 1 cannot start, 2 cannot start, because if 1 is starting, it's going to give me 1,000 something. It's not up to 5,000. 2 cannot start, it will give me 2,000 something. 4 cannot start, it will give me 4,000 plus, 4,500 and something, 4,600, 4,200, 4,100. So it means 4 cannot start. So the only number that can start is 5 and 6. 5 and 6. And don't forget that I'm not talking about only the first condition. The last condition too is there. Condition for first digit is here because it must be greater than 5,000. Condition for the last digit is also there because it must be what? It must be an even number. So it now become something that is very, very, I need to be very careful in dealing with it because of the fact that 6 here can occupy first position, it can also occupy the last position. So you have to be very careful. So I need to separate 5 and 6 here. For my first assumption, I need to assume that 6 is not starting, but 5 is what? 5 is starting. Exactly. So I need to assume that what? 6 is not starting, but 5, so that I want to resume, I want to what? Leave 6 to end. I want to reserve 6 so that it can also what? Be a number that we end. So in such a case, I will say that what? 5 is only 5 that can start. So I have one option, one number that I can put here. I'm going to do the one that 6 will also start down here. So whatever I get in the first one, I'm going to add to this one. So here 5 is starting. Here 6 is going to start. So if 6 starts, definitely 6 cannot end. If 5 starts, 6 can still end. So that is the logic. If 5 is starting, 6 can still end. But if 6 is starting, 6 cannot end because there must not be repetition of digits. 6 should not occur twice. So if 5 is starting now, I'm going to have one way. I have just one option to put here. I will now go to the last one. So the last one, I still have 3 options to end. I have 2 can end. I have what? 2 can end, 4 can end, and 6 can end. So I have 3 ways. I still have 3 ways of ending. So I can eventually pick any of the 3. Now to fill these 2, I don't have any problem. I'm going to have filled one number here, I filled one number here out of 5 numbers. So I'm going to have 3 numbers left. Any of the 3 numbers can be here. So I have 3 for this one. Any of the, if I eventually pick one number here out of the 3 numbers, the remaining 2 can be here. Any of the remaining 2 can be here. I have 2 ways of filling this place. So it means if 5 must start, I have 1 times 3 times 2 times 3 ways. 3 times 3 is 9 times 2, that's 18 ways. Now, if 6 must start, it means I'm still having one number that can start. Now, I will now go to the back. If 6 is starting, it means 6 cannot end. So for those numbers that can end, I only have 2 and 4. So I have 2 options there. So eventually I'll feed this one, I'll feed this one too. I have out of 5 numbers, I have 3 left. I want to fill the remaining position. So it's still the same thing as 3 permutation 2. Or you say 3 ways, 2 ways. 3 permutation 2 will still give us 3 factorial over 1 factorial. That's 3 times 2. So in this case, I have 1 times 3 times 2 times 2. That's 2 times 2, 4, 4 times 3, 12. So I have 12 ways. So it means for 4-digit number, I have 18 plus 12 ways. That's what? 30 ways of filling it. I have 30 ways of filling it. For 5-digit number, I have 72 ways. So if I add 72 to 30, I'm going to have what? 102. So I think I explained the same thing last week. So that is how we can solve don't forget what we have done here is for 5 digits. This is for 5 digits, while this is for 4 digits. So that is that. So let me go to the next. I'm not doing, okay, will I do this? Let me just do number 4 and leave it. Leave the remaining one for you. In how many ways can there 5 boys and 3 girls sit in a line if the girls must not sit next to each other? If the girls must not sit next to each other. In how many ways? Can anybody do this one for us? In how many ways can 5 boys and 3 girls sit in a line if the girls must not sit next to each other? If the girls must not sit next to each other. In how many ways can 5 boys and 3 girls sit in a line if the girls must not sit next to each other? Any idea? Okay. I've not seen anybody raising hand. Okay. Now we have 5 boys and what? 3 girls. So they are sitting in a line. And in this case now, if the girls must not sit together, so it means what we can just do is to first arrange the boys. Exactly. First arrange the boys. The boys are 5. So you can arrange them A, B, C, D, E. You can arrange them like this. If you have arranged them in this manner, in how many ways can we arrange the boys in this manner? That's what? That's 5 factorial or 5 permutation 5. I believe you get that right. Did you get that right? Precious, can you just nod? At least I can see you. You are using your video. Can you just nod? Okay. Okay. So you can you just nod that you get it? 5 factorial. Okay. Well, I want to assume that you are nodding. 5 factorial, yeah. So A, B, C, D, E, that's 5 numbers. It can be what? In 5 factorial ways. Now, the girls, the first girl, you can put it here. You can put her here. She can stay here. She can stay here. She can also stay here, and she can be here. She can be here. So that's how many? 1, 2, 3, 4, 5, 6. So it means the first girl can be in what? See, you can put the first girl because you have to go and place her in between the boys. Just place her before the boys or after the boys. So you can place her here. 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 Place her here. So that's 5. That's 6 ways. The second girl, if eventually the first girl occupies this particular position, the second girl can be here. 1, 2, 3, 4, 5. So she can be what? 5 position. If eventually she occupies this particular position. The third girl can be here. 1. She can be here. 2. She can be here. 3. She can be here. 4. That's 4 ways. Now, because of, okay, so since they are not identical, so you don't need to divide by anything. So in that case, you have 5 factorial, which is 120, multiplied by 6 times 5 times 4. 6 times 5 is what? 30. 30 times 4 is what? 120. So 120 times 120 will give us 14400. So if they must not sit together, and if they must sit together, how do we do it? We have done something similar. If they must sit together, it means you tie them together. So when you tie them together, they become just one entity. Add them to the boys, you have 6 entities in all. So if they must sit together, for must sit together, they did not have such a question, but for must sit together. So in such a case, you are going to have what? You have 6 entities in all. Then how many ways can we now what? Arrange the girls. So we can arrange them in what? 3 factorial way. Because there are 3 non-identical girls. So that will be 3 factorial ways. So 6 factorial is 720. No? Yeah. 6 factorial is 720. 3 factorial is what? 6. So that will be what? 4. That's 4, 3, 20. So that is that. I think at this junction, we need to relax and move to combination, because our time is fast spent. We have just little time. So these are some of the questions that you have to go through. So I want to believe you can actually go through these questions. So I expect you to go through this. So can I give you the next 5 minutes to work on this question? Number 7 and number 8. So I give you the next 5 minutes. You are submitting it, please. I'm giving you the next 5 minutes. The next 5 minutes. Everybody must do it. So please, I want you to have something, just a trial. So in the next 5 minutes, so by 6:26 or 6:27, I'm coming up again to hear from you before I go to combination. Thank you. So do we have anybody? Welcome back. Do we have anybody that is ready to present? Igwe Victor, you want to present? Do we have anybody that want to present? Can somebody say something there? Okay. If there's nobody to present, I think I won't go over this. I'm going to the next. So these are some of the questions. I know you must have got them in your notebook. Like I told you, in this particular case, combination. So the concept of is selecting. We are choosing, we are forming. In this case now, we don't need arrangement. For example, I need to select. For example, I need to select some people for an assignment to do something for me. So maybe in a class of 25 students or in a class of 10 students, for example, I just pick 2 people to do something for me. So the 2 people may be A and B. So it doesn't matter if I pick A first or I pick B second. So it doesn't matter. Picking A, B, in this case, is the same thing as picking B first and picking A second. So it's still the same thing. So A, B in combination, AB is same thing as BA. But in permutation, AB is different from BA because permutation deals with selection and arrangement. While combination solely deal with what? Just selection. We are not concerned. That's why they say order does not matter. Order does not matter. So as a result, that's the reason for the formula. So it means the formula for combination N combination R will be given as N factorial, is similar to that of permutation. N factorial over N minus R factorial. But because of the fact that there will be repetitions if you continue to what, if you swap them like this, A, B, B, A. So in such a case, we are going to have what? Over R factorial. Coming? Just give me a few seconds. I think my power is having issue here now. Coming? I'm good to. Okay, I think yeah, the problem has been resolved. So so that these are formula for combination. So that's the formula for combination. N combination R equals N factorial over. Okay, so that is it. Now let's move. So that's the formula you can see here. Now, to find combination of N items from R items. To find the number of combination of N items choosing R at a time. So we can use this particular formula that you have there. Now, there are some things that they want us to simplify. You can see the first one there, they says simplify. So I'm going to, let me just rule this place and solve here. So the first one, I want to solve the second one first. The second one says 3x combination 2, 3x are together, equals to 15. So they want us to find the value of x. Don't forget from the formula, this is the formula. It means 3x combination 2 will be what? 3x factorial divided by what? 3x minus 2 factorial. Then what? 2 factorial, which will be equals to 15. Don't forget last week we dealt with how we can simplify factorials. So you look at it, this factorial and this factorial, which one is greater? The greater of the two is 3x. So how do we reduce 3x? 3x factorial is same thing as 3x multiplied by 3x minus 1. You continue to reduce it by 1. Multiply by 3x minus 2. You reduce it by 1 again. Up to the level of the one here. So the level of the one here is 3x minus 2. So you stop there. But when you are stopping in such a case, you put factorial there. Divided by 3x minus 2 factorial. Then 2 factorial. 2 factorial is 2 times 1 equals to 15. So 3x minus 2 factorial, 3x minus 2 factorial. We are left with what? 3x multiplied by 3x minus 1, which is equals to, if you cross multiply, it will be 15 times 2. That is what? 30. So that is 30. So I can actually divide through by what? 3. If I divide through by 3, it is 2 times 15 that give us that's 30. So if I divide by 3, I have x multiplied by 3x minus 1 equals to 10. So it will give me a quadratic equation. Can you just expand? I have 3x squared minus x equals to 10. But this 10 can come inside and become minus 10 equals to 0. So what are the factors of 3 times 10? You multiply by quadratic equation. I think it was part of what we discussed at the first class. 3 multiplied by 10 will give us 30. What are the factors of 30? We have 1 times 30, 2 times 15, 3 times 10, 5 times 6. So which one will give us minus 1? So it is 5 and 6. But the two must have different sign. For it to give us that, it means we must have plus 5 minus 6. So instead of having minus x now, I'm going to replace it. I'm going to have 3x squared minus 6x plus 5x. Minus 6x plus 5x will give me minus 1. Minus 10 equals to 0. So here 3x is common. Here 5 is common. So 3x, x minus 2 plus 5 is common. X minus 2 equals to 0. So from there I have 3x plus 5 then x minus 2 is common, equals to 0. So 3x equals to minus 5, x equals to minus 5 over 3. Then, or x is equals to 2. So either of the two. But because of the fact that when you find, if you want to get 3x now, we need 3x actually. And that 3x must be an integer, a positive integer. So 3x in such a case will be 3 multiplied by minus 5 over 3, which will give us minus 5. So it can't be minus. So it means our answer can't be minus 5 over 3. So our answer will rather be what? X is equals to 2. Because by the time you substitute this, 2 times 3 is 6. So 6 combination 2. So it means the value of our x is 2. So that is the solution to that particular one. Then looking at the next question, the first one. Looking at the first one, do I have an extra space to? I believe you have written this one. So let me go to the next question. That's n plus 1 combination 4 minus n minus 1 combination 4. Okay. I still need to get a space here.
Sir, your microphone is muted.
Oh, sorry. Thank you very much. So I have n plus 1 factorial over n plus 1 minus 4 factorial, then 4 factorial. Minus, if you are going to do for n minus 1 combination 4, it will be n minus 1 factorial divided by n minus 1 minus 4 factorial, then 4 factorial. So in such a case, we are going to have it as n plus 1 factorial over what? N plus 1 minus 4 will give us n minus 3 factorial. 4 factorial. Minus n minus 1 factorial over n minus 5 factorial 4 factorial. So in this case, you look at, this is n minus 3, this is n minus 5. Which one is greater? N minus 3. So you can reduce to the level of n minus 5 so that it will be common. N plus 1, n minus 1, which is greater? N plus 1 is greater. So maybe I will just give you the idea. I may not be able to finish the solving because of time. So n plus 1, I can reduce it to n plus 1 n plus 1. If you remove 1 from n plus 1, you have n. If you remove 1 from n, you have n minus 1. So stop here, factorial. Over n minus 3 is also what? Greater than n minus 5. So also reduce it, n minus 3. The next one, if you remove 1, n minus 4. Remove 1, n minus 5. Factorial. Then 4 factorial. Plus n minus 1 factorial. Okay, sorry, it is minus. Minus n minus 1 factorial, n minus 5 factorial, 4 factorial. So what is common? N minus 1 factorial is common at the numerator, n minus 1 factorial. At the denominator, n minus 5 factorial is common, and 4 factorial is common. So into brackets, in this place, you have n into bracket n plus 1 left, divided by, here you have n minus 3, n minus 4 left, minus, and you have 1 left here. There's nothing left here. You have invisible 1. So by the time you find the LCM of this one, it will bring something, and then I don't want to waste time on this. Okay, so let's see. If you apply that, you have n minus 3, the LCM. I just want to deal with this LCM, n minus 3, n minus 4. Then in this case, multiply. This one will give you n squared plus n. Then this one, this minus 1, if you do the LCM, and it will give you the multiple of this. So if I should do that, I'm going to have n squared minus 7n plus 12. So, and by the time you subtract here, the n squared will cancel n squared. So at the end of the day, you are going to have plus n plus 7n. And that will give us, it will later give us, that's 8n. Is that? Yeah, it should give us 8n. I want to see whether it will make any sense there. Will it make any sense? Okay. Yes, it will give us 8n plus 12. Just go and work it out, and then let's see if there's any different thing that it will give us. So at the end of the day, let me just give you the clue. What will happen is that this one, you can still combine it with this. It will still give you n minus 3 factorial. Then by the time you combine these two, we are hoping that we can get n plus 1 and n there. So by the time you combine that, we should also be able to get something like n plus 1 factorial or n factorial. So that is the intention there. So you can also try it. Get back to me. I will guide you on what other things to do. So quickly, we may not be able to go over number 1, but if you look at number 2, the question there is, out of 11 girls, 4 are to play table tennis. Let me see. Okay, I didn't. Okay, I just created space for that. 10 are to play table tennis and 7 netball. Each of the girls can play both games. How many ways can 2 groups be formed? In how many ways can 2 groups be formed? So we want to form. So in this case now, you see that all of them are 11 in number. So they are 11 in number. So we have four to play table tennis. So it means in how many ways can we get 4? So we are going to get 4 from 11, and we also get 7 from that. So if you are starting from 4, want to pick 4, so it will be 11 combination 4. So I haven't picked the 11 combination 4. It means we are going to be left with 7 people left. So all the 7 people will fit in for what? For netball. So that will be what? 7 combination 7. And that will just be what? In one way. So one thing that you can just look at here is that it may be that we are selecting 4 people first, or we are selecting 7 people first. So whichever way. So it will still give us the same thing. Even if you say 11 combination 7 multiplied by the time you pick 7 people, you'll be left with 4. 4 combination 4 combination 4. So either of the two ways. It may be that you are going to select table tennis first, people that will play tennis first. So the many people will just go and play netball. Or you select those people that will play netball first, so that the many people will just go and play, the remaining 4 will just go and play so in this case now, if you do this 11 combination 4 multiplied by 7 combination, 7 combination 7 will give us 1. 4 combination 4 will give us 1. Then what is 11 combination 7? So what is 11 combination 4? So that is how you are going to do. So whatever you get here, you add it to what you have here. So quickly. Then the next question, you have 3 students are to be selected from 4 boys and 3 girls to represent their school in a mathematics quiz. In how many ways can the 3 students be selected if there is no restriction? For that question, if there is no restriction, 3 students are to be selected out of 9, 4 boys and 5 girls. So if there is no restriction, it means you add them together. We don't want to know boy or girl. Add them together. We have 9 people, 9 students. So out of 9, we need to select 3. That's 9 combination 3, which is 9 times. By the time you do it, you should have 9 times 8 times 7 over 3 factorial over 3 times 2 times 1. So you should have something of that nature. But now they said if more boys than girls will be selected, if more boys than girls will be selected, if you do this, you should have 3, you should have 4, 3 times 4, 12, 12 times 7. I think that should give us 84 or so. Then if more boys than girls, we are selecting 3, and we have 4 boys, and we have 5 girls. We need just 3 people. We need to select just 3 people. So in how many ways, how do you do that? They said if you must have more boys than girls. So you can first say that all those people that you are selected are boys and no girl. That will give us 3. Or you have 2 boys and 1 girl. That will still give us 3. So that's the only option. The next option is 1 boy and 2 girls. And in that case, the girls are more than the boys. So we want the cases or situation in which the boys will be more than the girls. So it is either this or this. So to get this, it will be you are picking 3 out of 4 boys, and you are picking no girl out of 5 girls. So that would be 4 combination 3 multiplied by 5 combination 0. 5 combination 0 will give us 1, actually. So plus, if you are going by this, that would be 4 combination 2 plus what? 5 combination 1. So you can go and do that. That should be the solution to that particular one. Number 5. So you can just, we have done combination. So I want you to go and apply that. The time is not on our side. So all those ones that I did not finish up, just go and do it. 11 combination 4 times 7 combination 1, 11 combination 7 times. So you add your answers. So for number 5, it said a committee of 5 members is to be formed from 6 men and 7 women. In how many ways can this be done if it consists of all women? They have told us that you have what? You have 6, you have, I don't want to do number 4 because similar to what we have done. Okay, you can see in this case now, they broke this one down. They say, how many ways can 12 people be divided into 3 groups? Into 2, 7, and 3 in that order. Here they have said it that in that order. This one, they did not say that 4 must be selected first before 7. That's why we did it in both ways. And we said we are going to add. We did it together in both ways. But in this case, they have said that what? In this order. So you must follow this order. So you can't do it in any other way. It means when you have 12 people, you first what? You first remove, select. In how many ways can you select 2? From 10, from 12. Multiply by, having selected 2 will be left with 10. In how many ways can you select 7? From 10. Multiply by, so having selected 7 from 10, you'll be left with 3. In how many ways can you select the 3 from 3? So this is the solution. You can go and finish it up. That's the solution to question number 4. Question number 5. So that is where I'm going to end today's class. For question number 5, all the questions here are also in the question that I gave you the last time. So at this point, let me also tell us that for those people that have not been able to join our WhatsApp platform, I will quickly post the link to the platform on the chat group. On the chat group, let me quickly do that now, because any moment from now we'll end the class. So in the chat room, I will quickly do that now. So for those just joining us, you can see the link there. So you can join the link. So a committee of 5 members is to be formed from 6 men, and 7 women. In how many ways can this be done? If all women, if it is women that we must watch, all the 5 must be women. So it means out of these 7 women, you are selecting all 5. We are selecting 5. So the answer to that will be 7 combination 5. It's only women that we are considering, no man. Then they said if 2 men and 3 women, okay, if it consists of 2 men and 3 women, if the committee is to be made up of men and women, okay, yeah. So you just say you need 2 men out of 6 men, and you need 3 men out of what? 7 women. 3 women out of 7 women. You know, we have 6 men and you have 7 women. So in such a case, we need 2 men. We need 2 men, then we need 3 women. So it will be 6 combination 2. We need 2 out of 6. Multiply by, we need 3 out of 7. That will be 7 combination 3. So that is the way of doing combination. So at this particular time, I'm going to pause here. If there's any comment that we want to take, we can quickly take that now and end the class. So next week shall be the last segment of the class. So I expect all of you there. So I wish you best of luck. And next week, we want to consider an aspect of calculus. So to end the class. Thank you very much.